Hi again. So these are going to be examples with more of the phasors and then complex numbers. So it's going to be a little review with sinusoids, but then move into mostly examples with phasor and complex number manipulation. So for this problem, which is 7.2 from the book, you're going to change it over first to, again, move this negative sign into the cosine portion. So that means that in order to get rid of this, you have to add 180 degrees to this one. So you're going to have I of t is going to equal 0.2 cosine 6 pi 10 to the 9th t plus 240 degrees milliamps. So the amplitude is going to be the 0.2, and it will be 0.2 milliamps because of the units. And then the frequency is going to be radians per second, so this is omega. And then your phase angle is going to be the 240. So again, this could be phi or theta, whichever term you want to use there, it's going to be the same. So when we have now a signal and we want to move it into polar form, that phasor, for a signal it's called a phasor, and we're going to do that transform. And so the phasor transform uses 0.2 milliamps as the unit, and then you do E J to the phi or theta, whatever, again, the variable you want to call that. Another way to write it, which means the same, these two are interchangeable, would be the big angle sign, 240 degrees. So either of those would be how you would express that. So also looking at maybe what quadrant this is in, thinking about 240, this is going to be in quadrant 3. All right, next example is looking at these waveforms and converting them into phasor form. So we're going to not concern ourselves with the lead and the lag, and we're going to just look at phasor transforms for these. So V1 is going to move into, you have to first convert it into cosine and also remove the negative sign out front. So it would be plus 4 cosine, and it's going to be 6 pi 10 to the 4th t plus 30 degrees, and then it's a minus 90, minus 90 plus 180, so plus 90 total. So this combined ends up being 120, and then when we make the phasor form of this, so your phasor of V1, so we'll call it phasor transform, this becomes 4E J 120 degrees, or again, you can write it with the angle sign, so 4 angle 120. For V2, it's already in the cosine form, so our phasor here is going to be 2E to the negative J 30 degrees, or again with the angle sign, 2 angle negative 30 degrees. So those would be your angles. Looking at the quadrants for these, 120 is going to be in quadrant 2, and negative 30 is going to be quadrant 4. So remember the quadrants, This one is 1, this one's 2, this one's 3, and this one is 4. All right, the next example, just a brief comment I wanted to go over was looking at phasors. The nice thing is when we have a differential in the time domain, it goes into j omega of the function and so that becomes the phasor form of that function in the frequency domain. And integration ends up being a 1 over j times that function. So these are really fun properties that we're going to get into a little bit more detail next unit. All right, getting back to the transforming. So again, the phasor form means polar. And so we want to convert each of these into its polar form. So first take the phasor transform. So that means that this is going to be needing to be changed into cosine. So 8t plus 75. And then sine to cosine, we do a minus 90. So this ends up becoming 10ej minus 25. Minus 75, 85, 90, minus 15 degrees. And this one, we bring in the negative sign into the cosine portion, so minus 25 degrees, and then plus 180. And so this becomes 17e to the 155 degrees. And the last one, we have to first convert into the polar form. So this signal becomes 8ej negative 45. And this one becomes a plus 5 cosine 6t plus 90 degrees. So that one becomes 5ej 90 degrees. And so from here, this becomes 8. So then to add them together, we need to change into rectangular form. So in order to do that, it becomes e cosine negative 45 degrees plus 8 sine negative 45 degrees. And this is the j portion. And then this one becomes 5 cosine 90 plus 5 sine 90 j. So from here, so I already wrote these out. So from this one, that 8 cosine minus 45 becomes a 4 square root of 2, and then the sine becomes a negative 4 square root of 2j, and then cosine of 90 is 0, and sine of 90 is 1. And so you add now the real portions, so 4 square root of 2 plus 0, and then you add, so the 4 square roots of 2 and 0, and then you add the 4 square root of 2, or negative 4 square root of 2 plus 5, and to the j's, which then yields the Cartesian or rectangular form. and then you need to convert into polar. So 4 square root of 2 is 5.66, and 5 minus 4 square root of 2 is minus 0.66. And so you then convert it back into polar, and so you end up with a 5.7 e to the minus 6.7 degrees. This first one is very easy. Again, converting the phasor goes 4, and then your angle, E minus J 30 degrees, and you can write it as 4 angle minus 30. And then the sign, negative sign, has to become cosine. So for that, you change it to cosine, and then it's a plus 90. And then adding those, you get 108. So 2E J 108 degrees, or 2 angle 108 degrees. So this would be your polar for that one. For this last problem, you're going to take the 3 sine 1000t plus 53 degrees minus 4 cosine 1000t minus 17 degrees, and adding them together, first convert into rectangular or polar first as the phasor, change to rectangular, add them, and then change them back into polar. So 3 sine becomes 3 cosine, and you just use minus 90 for that conversion, and then change that into the polar form, 3e to the minus 37 degrees j, and then the conversion is 3 cosine minus 37 plus 3 sine minus 37 j, and that ends up being 2.4 minus 1.8 j. And then you're going to do the same thing with the minus 4 cosine, 1000t minus 17, so that becomes 4ej. You'd bring the minus sign in and then add plus 180, so that becomes a plus 163. And then 4 cosine 163 plus 4 sine 163j, so that becomes a minus 3.825, and then a plus 1.2. So adding those together, I get the rectangular form, minus 1.425 minus 0.6, which note is going to be in your quadrant 3. So remember, when you do quadrant 3, sometimes in your calculator you'll get a positive number, but then you need to add in the 180 degrees to that in quadrant 3. So this then becomes the square root of 1.425 squared plus 0.6 squared e j inverse tangent of a minus 0.6 over a minus 1.425. And again, this is going to be a positive number, so you're going to have to add 180 degrees plus this inverse tangent of 0.6 over 1.425. And that will give you the right angle, which in this case is 203. So this is 1.5 EJ to the 203 degrees is your final answer here. So for the problem 7.28, you're going to do the same thing. Again, convert the cosine into that phasor form. From the phasor, you change it into rectangular form, add them, and then change them back into the polar form. So for this first one, 20 e raised to the minus 30j, and then this becomes 16 e to the 15 degrees, positive, it should be positive 15 degrees. That was miswrote there. Okay, so plus j 15 degrees. And then you take the 20 cosine minus 30 and the signs for the y's, add up the real numbers together and the imaginary, and you get 32.775 minus 5.86j, and then convert that back into the polar form. You get 33.295 and a minus 10 degrees. And then for 14 sine, you change to cosine, so you're going to have a minus 90. And for the minus cosine, you're going to have a plus 180. So then again, convert those into the phasor. So there's the phasor form, and then change them back into rectangular. And then add their values that are the same. So the 9.9 and a minus 8. And then minus 9.9 and a minus 14.272, and then you're going to be with a rectangular form, and then change that into polar. And the last one, you have again a minus sign here, so you have a plus 90 for this one. And then when you convert it, you go to rectangular form and then back into the polar form, and you end up with 7.3 EJ to the 74 degrees. All right, the last problem is a little bit different, where when you're solving a circuit, some of the time you're going to have, now we've done with mostly rectangular form to add and subtract, but sometimes you're going to have multiplications and divisions. So in this case, you have a current where you have a voltage over a impedance, which contains both a resistance and then a J component, which is going to be one of the, either an inductor or a capacitor. And so you change first the signal, which is going to be changed from 50 cosine to 50 EJ to the plus 155 degrees. And then this would be your Vx, and then to divide, you're now going to convert everything into polar. And so you're going to change the bottom into 24 squared plus 1.05 squared, square root of that, and then take EJ to the inverse tangent. So now you divide the actual magnitudes, and then for these, when you multiply, you're going to add them together, and when you divide, you're going to subtract. So 155 minus, so this is 155 minus 2.5, and that ends up being a 152.5 degrees, and then 50 over 24 is approximately 2. And so this would be your final value for something like this. All right, thank you for watching all these examples.